Morning, afternoon, or evening. Okay, so what we're looking at today is we're just going to do, assuming this will be after Easter for you, for this particular year anyway, we're just going to do a summary because we're at the end of derivatives. I'm going to do a summary today of our content in derivatives. So let me just pop open the Blackboard here. And what we'll look at today is we'll just kind of do a brief summary. There's a formula sheet that I put up in this day 15, that covers the power rule, definition of derivatives, the product rule, the quotient rule, the chain rule, and of course, it doesn't really have any rules for implicit differentiation other than the fact that it uses the same rules, but you have to add in a y prime in there. And those are basically all the areas in derivatives that we had. Okay. Of course, I didn't put any line equation formulas or anything like that either on that because it's just derivative rules. But when you get your formula sheet for the derivative exam, which will be coming up later, you will have the line rules and slope rule, m equals y1 minus y2 over x1 minus x2 and all that kind of stuff, in case you need it. Okay, so what are we going to do today? Let's take a look here. Okay, and today is day 15 of derivatives. And this is, we're done all our content basically. Implicit differentiation was our last bit. We didn't quite get derivatives done before we had our break this year. But here we have, a little bit of a summary today. So I'm going to look at, make a formula sheet. Sheet for derivatives. Okay, I already made it. It's already up. You can print it off. I'm also going to do a summary of the derivative unit a little bit today, and just go through some summary stuff. And then tomorrow we'll start our hand-in on derivatives, and then we'll do another video on the outline for the quiz, and then we'll do the quiz, and then we'll be into the graphing part. It's a real short unit next. It'll be like boom, boom, real quick. Okay, so that's all I'm going to do today. So let's start off by popping open the derivative formula sheet that I created. Now, recently I've been converting everything over to PDFs slowly now that I have a little more time. Okay, so if we bring this over here. Okay, so this is the derivative formula sheet that you can use at the end of the unit here. Here's all our derivative stuff. Okay, there's no approximation stuff on here. There's no limit stuff on here other than maybe the definition of the derivative. So derivative is used to find rate of changes. If we have a curve f of x, the derivative x prime x is at a given point x represents the slope of the tangent line at that point. So basically we're looking at derivatives being slope areas. Okay, so here is the definition of derivative. We don't often use this when we're doing derivatives, but I will have one question on it, the hand-in, that you have to use this particular formula to find the derivative dy dx or y prime or f of x prime. You have to take the limit of the function when you add h minus the limit of the function divided by h when h approaches 0, remembering that h is the distance between the actual point that you're trying to find the derivative at and chord lines as you bring them closer and closer and closer and closer to 0 until you get a tangent line. Okay, so the power rule was the first derivative that we did. Okay, derivatives of any constant, of course, but doesn't have the variable x on it, is just a 0. But if you have an x, it's to some power, then the derivative f of f prime x is you bring the power out front, then you subtract 1 from the power of the x. Okay, if there's already a number out front, you just multiply that number also by the number that was exponent. So if there's a number out front. Okay, the product rule, if we had an expression where we had two f and g, our polynomial expressions multiplied together, the f prime of x would be the big capital F, meaning the whole expression, would be f g prime plus f prime g. Okay. The quotient rule, similarly to that, if you have f over g, remembering g of x cannot be 0. I didn't put it in there, I forgot, but that's f prime g minus f g prime over g squared. Okay. And of course, the chain rule really, the rule for it is if you have some expression where y is a function of u and u is a function of x, so you're doing some substitution, then dy dx, derivative of y with respect to x, is equal to the derivative of y with respect to u times the derivative of u with respect to x. Okay, and then you can throw combinations of the chain rule in with the product and quotient rule as well. Okay, so what we're going to do then, you should probably print that off for your help. And then we had implicit differentiation as well, which used the same rules, but we had y as a part of the expression, so that we had to, whenever we had a y expression, when we took the derivative of a y expression, we had to add the y prime in and solve for the y prime at the end. Okay, so that was what we were doing in derivatives this unit. Okay, so what I would like to do is just summarize it a little bit, okay, by doing just a few derivatives to remind ourselves. So again, if we were doing definition of derivative, there is going to be a question on that for sure on the hand-in, probably not on the exam, but on the hand-in for sure. So it's a long process doing a limit, but it's not really that important once we get into the rules. So just remind ourselves the power example. So let's just do a couple of summary examples. So get my marker out here. We'll go to skinny line here. So just power rule. Okay, if we're looking at power rule, okay, so if we had something like y equals 3x squared minus 8x cubed plus 9, okay, where what we do is treat each of these as a power rule. Okay, the minuses and plus, when you're minusing and plussing different terms that are to some power, you can still use the power rule through them. The only time you can't do that is when those terms are minused and plussed and they're also raised to another power or taken a square root of or a cube root. Then you have to use the chain rule. But if there's no other connection or multiplication in here, you can then just do the power rule for derivatives. So if you try that one, 6x minus 24x squared plus 0. Okay. Obviously, we can factor that if we need to, which we'll be doing later on, but that's our derivative, which would represent the slope of the line, or the curve, pardon me, not the line. This would be the slope of the tangent line at any point along this curve right here, which is a cubic curve. It's negative, so it starts up here and goes something like that, if you remember your pre-cal 30 stuff. Okay, so that's power rule one. We didn't find too much worries about that. Okay, and then what came along after that is we had a little bit of product rule. Okay, so when we did the product rule, where we're looking at two functions multiplying together, so if we said y equals, and we had a bracketed term, let's do x squared minus 3x to the power of 8, bracket, okay, 2 x cubed minus 7. Okay, so we could expand that out if we wanted to and then do the derivative. But if we treat each of these as different products, remember they're not to any power here. If they're up to any power, then we have to use the product rule and chain rule together. But if we're just doing the product rule here, okay, if you remember the product rule was f g prime plus f prime g. and we just work it out in one line. Okay, you could do little notes like I like to do sometimes. If we just do it in one line, we take the F part. Okay, and then we multiply by G prime. G prime would be 6x squared. Okay, minus 0. Okay, so that's good. Plus, okay, then we would do F prime, which would be the 2x minus 24, because 8 times 3 is 24, x to the 7th. It's a bracket there. Times G, which was second one. Okay, and I'm going to let you leave it in that form and not have to reduce them during hand-ins, and it'll say in the directions, do the first step or something like that. Simplify where available or something like that, but not simplify right down or leave in factored form. Okay, so that would be the product rule one. Then we went into a quotient rule example. Okay, if we had a quotient rule, something like, say, 9x, y equals 9x squared minus 8x all divided by 3x cubed, or no, let's go 3x to the fourth. Okay, so if we were doing the quotient rule, we were following the quotient rule, which if we know that's f prime x, f prime g, I like to leave the x part out, minus f g prime all over g squared. Okay, if we use that, and we just kind of work it out here, so f being the top and g being the bottom, okay? G squared, pardon me. Okay, so f prime, we got to take the derivative of the top, so that's 18x minus 8 times g, which was the bottom, times, or subtracting f of x, which was the top, times the bottom derivative. Bottom derivative is 12x to the third. Okay. And we have everything over g squared, so that's 3x to the fourth squared. Okay, we can do a little bit of reduction there. Simply. Okay. We're definitely going to be able to take out 1 3x to the fourth there, 1 3x to the fourth there, and 1 3x to the fourth there. So we can take out 1 3x to the fourth. Well, actually can't take out 3x to the fourth. We can take out 3x to the third, because that's 3x to the third. So we'll do some reduction, simple reduction. So I'm going to put the 3x to the fourth out front here. I'm going to put 12 minus 12x cubed out front. Okay, and then when we do the squaring of this is 9x to the 8th. Okay, so we can see that we can kind of reduce a little bit from the bottom and the top. We can take out a common factor of 3, 3, and 3 from, remember this is one term, this is one term, and this is one term, so we have to divide out everything because of this minus in there. So we're going to take out 3, and we're going to take out 3x's, 3x's, and 3x's. Okay, so this is going to become x times 18x minus 8, taking out 3x cubed out of everything. Minus, okay, if I want to do 3x cubed out of this, this is 4 times, because I'm taking the x cubed out, whatever that was, Okay, and then I have to take out a 3x cubed. So that would be a fairly easy reduction there. Now, you might just leave it like this if I say do the first step. But you can do some easy reductions on that. And that's the quotient rule. Okay, then we got into the chain rule after that. Okay, so we're about 15 minutes in. I want to go about another 15 here. Don't want to go too long. Remember, chain rule. Okay, so this is where you're chaining them together using dummy variables if you need to. So these would be typically, if you had something, typically the chain rule comes in if you have square roots, cube roots, whatever kind of root things. So let's do one of those. Say we had the cube root of x squared minus 4x cubed. Okay, under that cube root sign. So rewriting that, this can be rewritten as a fractional exponent. So this would be x squared minus 4x cubed all to the power of 1/3. Okay, this binomial is the power of 1 under there, and this is the power of third. So it's 1/3. Cube root means power of 1/3. Okay, now we have to treat this like a chain rule. So the chain rule says that we treat this as a variable, take the derivative of it, and then we also take the derivative of what's inside with respect to x. So if we do it in one line, it would look something like this. Okay, treat that as a variable. So 1/3 x squared minus 4x cubed. 1/3 subtract 1 is negative 2/3. Okay, and then times the derivative of what's inside with respect to x. 2x minus 12x squared. So that would be using the chain rule. Now, of course, we could do a little bit of reduction here. Okay, take out a common factor if we want, stuff like that. But we can leave it like that. If I say leave it like that, if we wanted to take out a common factor, we could take 2x out of both of these, put it out front here, because we're multiplying them. And remember that this negative means that it's on the bottom of a fraction. And what some people have wondered, how do you change it back into roots from powers? Remember, like if you have something like this, what that actually means is x is on the bottom of a fraction, right? Because of the negative. And it also means that it's the denominator represents what's in the notch of the root. So if you go and do the root, this denominator is in d-notch, right there. That goes in d-notch. This number goes here with the expression. Okay, this negative simply means that you have to put it on the bottom of the fraction. Okay, and that's just your exponent rules from grade 11 pre-cal, I think. Okay, but I'm not going to worry about having you convert those back to root forms. Okay, most of the time, unless you take calculus in university, they won't expect you to do that here in high school, as long as you can work with this expression. Okay, so that was the chain rule. Now, another thing that we did along with the chain rules, we kind of chained a couple of things with the product rule together with the chain rule. So product or quotient rule together with it. So if you had something like this where we have to use the product and chain rule together, so say y was equal to the square root of x squared plus 3 multiplied by, let's say, 3x squared minus 5x. So this should chain up a product rule here. And we have to use the chain in here because this is to a root. So we're going to have to change that into an expression that looks like this. Okay, so we can just do this all in one step if we prefer to do f and g. So let's say f was equal to this x squared plus 3 to the power of 1/2. Okay, and we got to use the chain rule right here. Okay, the chain rule would say that it's the derivative of this after you've treated that like a variable and taken the derivative. So you treat that like a variable. I'm not leaving enough space there. Let me. Do it underneath because I'm not going to leave enough space. Okay, so it's going to jam it in there again. Okay, so f was equal to f prime would then be 1/2 of this whole expression. Okay, and then we got to subtract 1 so that we get to the power of negative 1/2. So that would mean that's the square root on the bottom, if you're doing root thinking in terms of roots, times the derivative of what's inside. Okay, and that's constant. G, on the other hand, would just be a straight power rule, no chain needed in this case. Okay, once you've done the chain rule in there, you then just slap it together with the product rule to get your full derivative. So y prime would then be equal to, okay, so we're going to do f prime g plus fg prime. That's what we're doing for the product rule. So take in f. Okay, you can leave it in fraction form like that. Multiply, f prime, pardon me. Don't want to confuse everybody right away. Let's start with f prime. That's how I started, but it doesn't really matter but because of the plus sign, but let's keep it the way I wrote it down. F prime would have been 1/2 x squared plus 3 to the power of negative 1/2 times 2x. Okay, times g. Now g was, where are we there? 3x squared minus 5x plus, okay, and then I've got to do the second part now. I got to do the f. Now I can throw the f down. X squared plus 3 to the power of 1/2, okay, and then I can throw the g prime down, which was 6x minus 5. Okay, and that's pretty good, a pretty good place to stop. If you want, you could maybe bring the 2 out here and multiply it by the half so that you can reduce a little bit. So this would end up being, I'm going to multiply that with the half so I get rid of that too. So this would just be x times x squared plus 3 to the power of negative 1/2 times 3x squared minus 5x plus x squared plus 3 to the power of negative 1, or power of 1/2, pardon me, times 6x minus 5. That looks nice and neat. Okay, we'll leave it like that. Of course, you could take, because you have this and this one's a negative and this one's a positive, you could try to take common factors out if we wanted to, but there's no need for it in terms of what we're going to do here in grade 12. So that's a combination rule. Okay, finally at the combination with a chain and a product. The final thing we did was a little bit on implicit differentiation. So let's take a look at one of those. And what an implicit differentiation type example would be. Okay, so this is where you get those expressions where you have y's and x's in them. Okay, so say something like this. 6 x squared plus 3 x y equals 9 y squared. Okay, so something like that. Okay, so the first thing that we're going to do is take the derivative. Now we have to be careful because this is a product rule in there because x times y, so you're going to have to use a product rule formula. So if you remember the product rule, if we treat it as like 3x times y, if we say f equals 3x, f prime would be 3. And if we say g equals y, g prime would equal y prime. Okay, so then the product rule states that it's f g prime plus f prime g. So f would be 3x times y prime. Well, let's just write it out without brackets, so it's not as messy. So we'd have f, and then g prime is y prime, plus f prime, 3, and g. So that's what goes when we take the derivative of this. Okay, so taking derivative of this is easy. 12x plus the derivative of this. Since it's all plus, we don't have to worry about putting brackets around it. Okay, and the derivative of this is 18y prime, because we have to add that y prime. That's the implicit differentiation part. So now we have to bring everything with the y prime to one side. So I'm going to bring it over here. So I'm subtracting 3xy prime. Okay, then I have to factor the y prime out on that side. Take the y prime out, and we got 18y minus 3x. Okay, we can see a common factor that's going to come out. Then we divide both sides by this bracketed term. Okay, that's a good expression, but we can reduce it a little. If we take a common factor of 3 out of the top, and 3 out of the bottom, we can simply cancel them. And then our expression would be that. Okay, so that's a little bit of a summary of all the derivative rules that we had, that we were working on during the unit. Okay, and this is the first year I'm recording, so this is for you guys here. So that was right after Easter. I don't know, maybe for other years if I use the same recording, it may not be. Okay, so let's take a look, okay, at what I'm going to give you next now is just the assignment. Okay, so let's take a look at it, the hand-in. And I'll probably give you a couple days for it. So I'm going to bring it across here as soon as I get to my Moodle page. Okay, oops, I don't have it down there yet. It's got to be up here still. Okay, so our derivatives hand, it says April 12th, but that was a couple years ago. That'll be whatever. I'll change that to whatever date we do it on for whatever particular year you're in. Okay, so the derivative, oh, that's a derivative quiz. Whoa, almost gave you the quiz. I want to give you the derivative hand-in. Derivative quiz, you're going to get that too, but let's go back here to the derivative hand-in, which is right here. It says March 22nd, which was whatever year. Okay, so this is the one we wanted. Okay, so here's the derivative hand-in. The other one was a derivative quiz, and we'll talk about that later in the unit. All right, so, and I'll be sending that out when we do that. Okay, this is what we're going to work on next period. So derivative 3 hand-in. So first one, using the definition of the derivative. So if you look and you're going to use that definition of derivative formula, that limit formula. So that's a long way to do it. Okay, so that one's a little bit ugly. Okay, the rest of it is, okay, it says using derivative formula, using the appropriate rules, do not simplify product and quotient rules. So you just leave them out, written out with the first step. So there we have that one. There we have that one. So you got 5 of them. Okay, this one here, obviously that's a power rule. Another power rule where you have to rewrite this as a thing. This should have been y equaling something. I missed the y there. Sorry, guys. And again, here, this should have been y equaling something. Maybe I'll adjust it and then I'll scan this in and put it up in a better way. Y equal. That's what I'll do. Allow editing here. And then, okay, so that's got the y in it. This one here, missing the y. Let's put the y in there. Y equals. There we go. And we'll do the same here for this one. Okay, that's a quotient rule that I'm putting in here. Y equals. Oops, not y, it's y equals. Okay, so I will print this one out and scan it in so that it has those changes in there. Okay, and this is a product rule, quotient rule, product rule with 3. Okay. Okay, here is the chain rule. Okay, straight chain rule here with powers. Another chain rule with roots. And a chain rule with 2 roots and adding in it. Okay, combination rule. You got to use combination rule. This is a product rule, chain rule. This is a quotient rule, chain rule. Okay, and here's a tangent line question. And a couple of implicit differentiations. Don't forget the product rule there. Okay, and that's our handed. Okay, so I'm going to print this out. I'm going to stop the video here. And that'll be open for you next day for you to work on. Okay, good luck. And standard rule will apply of 1 week. I handed it.